All right, welcome to the North Carolina Plumbing Code class. We're getting close to the end. We've covered chapter two, we covered the definitions. Uh, we talked about what's developed length, having access to something, ready access to something, just a number of definitions. You might want to go ahead and, if you can go back through those quizzes, the notes you've taken, it's always good to give a review. Chapter three with general regulations, looking at the pipe supports as far as what's the maximum distance between hangers on different types of pipe, whether it's 3/4 inch CPVC water line, or is it 2 inch PVC drain pipe. You can look at the difference and it'll give you both horizontal and vertical support distances. Testing and inspection. When are those required? What's required for it? What kind of test? And how long does it need to hold? We talked about excavating and backfilling, all sorts of information there in chapter three. Chapter four, fixtures, faucets, fittings. We talked a little bit about the different fixtures, some information about those, and then minimum facility requirements. That was in chapter four. Chapter five was with water heaters. Talking about some of the safety devices with the water heaters. Where can you put a water heater? Can it be in an attic? Can it be in a crawl space? Can it be in a closet? Um, and if so, what types? The difference between electric and gas. When do you need to put a pan for a water heater? Where do you pipe the pan drain off to? So a lot of information about water heaters in chapter five. Chapter six, water supply and distribution. And then in seven, we covered sanitary drainage. Chapter eight, indirect and special waste. Chapter nine, vents. And then the last time video that you had was chapter 10, traps, interceptors, and separators. So now we're getting into chapter 11. It's a short chapter. Storm drainage. And that's what we're covering this time. We're on page 87 of the North Carolina Plumbing Code. And then as soon as we go through this, I will go over the questions as far as what you'll have for your quiz here. Okay. All right, let's get going. Chapter 11, storm drainage. The scope of this chapter, the provisions of this chapter shall govern the materials, design, construction, and installation of storm drainage, except 1 and 2 family dwellings. So, except those residential. So, if we had a question, and I think we'll cover it on the quiz, I'll say, does chapter 11 with storm drainage cover how to handle a storm drainage for residential? And no, it doesn't. Okay, it's not covered for that. This is for commercial applications and purposes for the storm drainage. So the disposal of it: rainwater from roofs and storm water from paved areas, yards, courts, and courtyards shall drain into an approved place of disposal. And that can be quite costly. If you get a place putting up and they've got to pave a parking lot and they've got roof area, and then they're catching all this water. We got a lot of water running off of this. They've got to provide and have something to do for this the storm drainage. We ran into some issues with it. We were plumbing up some homes in a development, and there was some construction going on just like up the hill elevation from us, and they had a big parking lot paved, and it caused a lot of water damage, and so they had to come in and do a lot with the storm drainage to take care of that. Let's see. Testing. Prohibited drainage. Stormwater shall not be drained into sewers intended for sewage only. So being able to do it, those are separated out. A lot of times stormwater and stuff that might end up running into a creek somewhere, just stormwater runoff. That does not go to the sanitary sewage system. Testing. You're going to test it just like you would the sanitary drainage system, though. And how do you do that? Where is that information found? In chapter 3 under testing and inspection, general regulations. The changing in size, just like the sanitary drainage. In chapter 7, it talks about you cannot reduce it in the direction of flow. The size of the drainage pipe shall not be reduced in the direction of flow. Same like that, same for storm drainage. Fittings and connections, they have to be approved. Go back and it refers you back to chapter 7 again. So a lot of this information you're going to see is going to refer you back to chapter 7. And you do have to put them in the proper direction of flow. Okay. Clean out should be installed in the storm drainage system and should comply with the provisions um, of Chapter 7. So once again, going back to Chapter 7 there, backwater valves. And we talked about that. I don't know if you remember with the backwater valve and when we have to have that, when you're looking at the upstream manhole. But storm drainage system should be provided with backwater valves as required for sanitary drainage system and with section 715. Once again, referring you back to chapter 7. Okay, let's look at some building storm sewer pipe. Table 1102.4 gives you different materials right here. So you're looking at those. And then you also have the next table under 1102.5 subsoil drain pipe. And it gives you approved material ABS, that black plastic piping. Okay. It also gives you some standards. So on the side of that pipe, you ought to see these numbers, or what are these numbers stamped on the side of it? Cast iron pipe, concrete pipe, copper alloy tubing. Jump down here, subsoil drain pipes. You got cast iron, PE, a polyethylene, PVC, polyvinyl chloride, vitrified clay pipe, or some terracotta there. Some of those are, you'll have to find it. If you want to use it for that application, it needs to be found in your code book. Just like chapter 6 when we covered as far as water supply or water service, water distribution piping, whatever you use has to be of an approved material. It's got to be able to be found in here. Right down to your primers and your glue and some gluing the pipes together. It's got to have that ASTM number on there to be an approved. Okay, roof drains. We're flipping over the page to page 88. It talks about fittings on 1102.7. Pipe fittings shall be approved for installation with the piping material installed. Shall conform to the respective pipe standards of one of the standards listed in table 1102.7. So just jumping down there, and once again, you've got approvals for your pipe fittings. Before it was the pipe. Okay, conductors and connections. Prohibited use. Conductor pipes shall not be used as soil, waste, or vent pipes, and soil, waste, or vent pipes shall not be used as conductors. The floor drains shall not be connected to a storm drainage. So we aren't allowed to, if you get down in, and I know you'll probably see some older basements at times where they had a floor drain in the house. And then if they had the side of the steps that kind of went down and they had a drain just outside the steps to where if water rained, it could pool down in there at the bottom of the steps going down to the basement. And a lot of times those were connected together. Often in the older homes, you'll see that only toilets went to a tank outside. Most everything else just kind of ran right out on the ground. That's not allowed anymore. We aren't allowed to do that. Let's see, roof drains. Roof drains shall be installed in accordance with the manufacturer's instructions. The inside opening for the roof drain shall not be obstructed by the roofing membrane material. Strainers. Roof drains shall have strainers extending not less than 3 inches above the surface of the roof immediately adjacent to the roof drain. Strainers shall have an available inlet area above roof level of not less than 1 1/2 times the area of the conductor or leader to which the drain is connected. Okay. So we're basically just saying if you had a roof up here and you did have a drain, okay, that was coming off for you got rain falling on here. Okay, it's raining outside. We're going to have water that starts to build up on the roof. Now, we're going to have to put some type of strainer also over this, because what happens if you've got leaves and other debris and whatever that's going to be up here, and you want to keep that out of here, but also, and you're just saying, well, why can't we just have a flat strainer across the top of it, like a shower drain or something? Well, in case we get some debris that's built up, because as things wash towards this and build up around here, we want to still have area to where water can go and go down this drain. Okay, and it says that shall extend not less than 3 inches above for that strainer. Okay, Flat decks. Roof drain strainers for use on sun decks, parking decks, and similar areas that are normally serviced and maintained, okay, shall comply with section 1105.1 or shall be of the flat surface type installed level with the deck. Now, so that's saying if this is going to be, if they got a storm drainage, maybe you've looked at a parking deck, someplace where you go, you're not going to have roof strainers like this. They're going to say, well, this is a regular serviced area that's kept clean. You don't want to stick these on there because now they become trip hazards and everything else. So you can do, you might see flat style on those. Okay. Roof drain flashings. The connection between the roofs and the roof drains that pass through the roof and into the interior of the building should be made watertight by the use of an approved flashing material. Okay. Let's now if you go look at page 89, what you have here is you've got some rainfall rates. Okay. If you don't have your book that you're looking at right there, this is what the chart is going to look like. You have this top chart. If you notice that that's the state of North Carolina. If you haven't looked at the LLA, okay, we got that's our state. We've got 100-year 1 hour rainfall in inches per hour for North Carolina for primary roof drains. Okay. Now they're going to give for the primary roof drain, saying this is the primary drains that's going to services the drains for the roof. Okay, they took over the last 100 years that we've had. They've looked and said, okay, what's the greatest amount of rain that we've had over a 1 hour rainfall? Okay, so it's been raining for settled in and rained for an hour. How much do we have in inches per hour? If you look at it, so we're over here, okay? So we're following close to right along this 3.5 inch maybe line, okay? Somewhere right in here. The mountains over here, we're looking at 3.5 to 3.25. If you go back down over here towards the coast, you're looking at closer to 4, okay? Now, when you jump down here for secondary roof drains, now this is over 100-year period for the 15-minute rainfall in inches per hour. So in 15 minutes, so if rain just comes up and it's just a rainy day, okay, and it just rains steady, okay, for a 1 hour rainfall rate. That means rain's coming in and it's raining for the hour, might be 2 hours, 3 hours. But in the inches per hour, when you get the kind of socked in for the day, it's going to normally rain more steady but slower. Okay. When you get those afternoon thunderstorms that come up, that just the bottom opens up and really dumps. Now those are going to be for your emergency or secondary roof drains, where you've got to say, hey, we have got a lot of water coming down and our primary roof drains might not be able to handle all this. We've got to have some emergency roof drains or something to where water's not building up on the roof. And so they're looking at for that 15-minute downpour. And let's just say that thing lasted for, we get that kind of a rate for an hour. How many inches per hour is that going to be? And then we size those accordingly. Okay. So that number down here is going to be a lot higher because this is kind of the downpour rain that we're looking at versus kind of a more steady rain that's lasting a longer period of time. You look at here, we're looking at 6.5, 6.6, 6.8, get to the middle of the state, 7.2, 7.2 over there at the coast. So you can see just some rainfall rates that they give there. Okay. They used to have a chart in here. They broke it down and had in I guess that was the code before this one. They used to list cities, some of your predominant cities in North Carolina, and would give rainfall rates for those various cities as well. Okay, sizing of size of conductors, leaders, and storm drains. That starts on page 88, 1106.1. Okay, the size of the vertical conductor and leaders, building storm drains, building storm sewers, and any horizontal branches of such drains shall be based on, and then it gives you these 100-year rainfall rates, and we've already looked at those charts. Okay, it says the vertical conductor and leader. So vertical is this way. Vertical conductors and leaders shall be sized for the maximum projected roof area in accordance with tables 1106.21 and 1106.22. Okay, the top one is for, it says size of circular conductors and leaders. The difference is down here. This is the size of a rectangular conductor and leader. Now, are they circular, like a pipe, or are they? We got a rectangular. Most of you, if you've got rain gutters on your house, you probably got rectangular, I'm guessing. But now you'll go into some fancier ends of town. Maybe that's where you live, is on the fancier end of town. And you might have, they've got copper gutters and copper downspouts, and they might have circular, some circular copper piping that you'll see on those. Those they even have, some of them even have alarm systems on their gutters, because they don't want people coming by and stealing their those their gutters off the house. Okay, but how you going to do this is, it takes, if you look at the left column, it's the diameter of the leader. Okay, it's for the circular ones. Down below in the rectangular, you're going to have it's going to say like 2 by 3 or a 3 by 4 or whatever. Okay, now the next ones is the numbers, the bold numbers across the top. Okay, you've got rainfall rate in inches per hour. Okay, 1 inch per hour, 2 inches per hour, 3 inches per hour, 4 inches, and so on. Then you have the horizontally projected roof area in square feet. So if you had a roof area, and we're looking at square feet, so if we said this was a 10 foot by 20 foot, okay, so what you do, how you figure it, is you take 10 times 20, and you'll come up with what? 200 square feet. All right. So if we had to have something that did that, now that's a very, very small, probably for roof area is going to have greater than that. But what do you need? What size, diameter of leader are you going to need to carry however many square feet that you came up with? Okay. All right. Let's see. A 2-inch. So if you look at this, a 2-inch leader, if you had, if your area that you're building in has, one rainfall rate of 1, well, let's flip over and say, well, what were we? If we are figuring, let's just figure on 4 inches. If we look back at that 100-year 1 hour rainfall chart, for us, it was like about 3.5. So let's just figure it on 4. We'll go over to 4. And if we go down to the 2-inch leader, that's able to handle 720 square feet, is how we're figuring that. So we find out where are we building, what's the rainfall rate for that area. And then you say, well, how many square feet roof do I have? And that's what size leader I need to be able to handle all that. Okay. All right, let's see. And you're doing the same thing with the bottom one as well. Let's see. Vertical walls inside roof drains and storm drainage, a piping 1/2 of the area, the vertical wall that diverts rainwater to the roof shall be added to projected area for inclusion in calculating the required size of vertical conductors. So basically, it's just saying, if you've got a flat roof and you've got a wall that's built up beside it, okay, and you've got this area that's tapered to where water is going to run, the wall that's built up, this area up on the top is considered calculated into the roof area. Okay, it gives, let's see. There's the what I'm looking for. Sizing and stuff of storm drains, emergency storm drains. Page 92. Okay. And it's getting this area that's cut away into the building, this buildup, let's just say these primaries become clogged or something, or not able to handle, and we got just too much water building up here. You'll also probably notice, you may notice up there that they've got this place cut away, and you might have them see this cover come over it, and a storm drain pipe coming down the side. Look at some of your newer restaurants that you come. Pull into a Taco Bell sometime. Just look up there. Look at the see how the roof is built up higher. Look and see if they've got some emergency drains on these. Basically, what it is an opening that's actually built up just a little bit, but it's this overflow area to where if water starts to build up, that thing is called a scupper. It just allows water to flow versus water building up in that area. Okay. They also give you, just the capacity of the scupper. The head in inches. That's by H here. The length of the scupper that you're needed. The capacity of the scupper in gallons per minute is 4, 6, 8, 10, 12, 18, 24. And then you got this is the length. The length is those. And then you've got the capacity of the scupper in gallons per minute. 10.7, 17.4, these numbers down in here. Okay. Table 1106.6. You got size of similar roof gutters. And so far, let's see. Let's look at. Let's flip over to page 94. Secondary emergency roof drains or scuppers. 1108.1. Where the roof drains are required, secondary emergency overflow roof drains or scuppers should be provided where the roof perimeter construction, like this right here, extends above the roof in such a manner that water will be entrapped if the primary drains allow buildup for any reason. Where primary and secondary roof drains are manufactured as a single assembly, the inlet and outlet for each drain shall be independent of those. So they're just saying, hey, if you're using the same drain, we've got to be able to. You're going to make the two are going to inlets openings for these things are going to be independent though. Okay. All right. Separate systems required. Secondary roof drains system shall have the end point of discharge separate from the primary system. Discharge shall be above grade in a location that would normally be observed by the building occupants or maintenance personnel. You want to know if that's clogged or not. And then they give sizing of the secondary drains. Actually, that's what we looked at for there. Let's see, what else am I going to have you look at? Subsoil drains, building subdrains. Building subdrains located below the public sewer level shall discharge into a sump or receiving tank, the contents of which shall be automatically lifted and discharged into the drainage system as required for building sumps. The sump and pumping equipment shall comply with section 11 of 13.1. Sumps and pumping systems. So if you're collecting this stuff and it's below where you're going to be, you can collect it and pump it up and out. Pumping capacity and head. The sump pump shall be of a capacity and head appropriate to anticipate the use requirements. The sump pit. These are very much like a sewage ejector pit that we've talked about previously in Chapter 7. The pit can be not less than 18 inches in diameter, not less than 24 inches deep, unless otherwise approved. Pit shall be accessible and located in such that all the drainage flows into the pit by gravity. So, which makes sense. If you're collecting it, it says no less than 24 inches minimum deep, 18 inches minimum wide, and then all this area, if water is going to get here, that it will run and drain into here. Okay. The pit should be accessible and located so that the sand draws by gravity into the pit. The sump pit should be constructed of tile, steel, plastic, cast iron, concrete, or other approved material with a removable cover adequate to support anticipated loads into the area of use. The pit floor should be solid and provide permanent support for the pump. And then it gives you, basically, you're going to have a pump down in here, pump discharge up and out on that. Okay. Discharge piping shall meet the requirements of section 1102.2, 1102.3, 1102.4, and shall include a gate valve, a full flow check valve, and pipe and fitting shall be the same size or larger than the pump discharge piping. On the so a gate valve, and then also a check valve. Check valve. So when this thing pumps and the water flows into here and it kicks on, it pumps up, but you've got a check valve in the line that doesn't let anything drain back down through. Now, of course, when you get to this point, this should flow by gravity. That should be pitched to where that flows by gravity. I did get a call one time. Somebody was, they had one of the, like a sump pit in their basement, and this was pitched wrong. So it was pitched this way, flowing back to here. Their check valve went bad to where every time it would just kick on and this would pump up and it would flow up this way, say, oh, it's closed. And so the pump would shut off, but all this water would just drain back down the pipe, down into here, and it would come back out and fill this thing back up, enough to where the float switch would kick it back on. And it was just sitting there going, and it would come on and off and on and off and on and off. On that. So we need to have this pitched right. We need to have the check valve went bad on it is what happened. And so it was just bleeding back down by the check valve. So I replaced the check valve and then also pitched the pipe appropriately to where if it did go bad, it wasn't going to keep training back down into the pit. You'll also have a shutoff valve on that thing to where you can turn the valve off and then be able to service your check valve. Okay. Let's see. And got any more? Let's see what I missed. Let's go over the questions that I asked you. There's not a whole lot that I'm really gonna need you to remember out of this chapter. We'll give you some questions, but all of this will be really designed for you. You're going to get into a commercial application. And if you are, as the plumber, if they have you do the all your rainwater and the gutters and leaders and everything else, it's going to have sizing and all that on there for you. Okay, in a straight run, you can have a maximum of 100 feet between cleanouts in a 4-inch storm drainage system. Is that true or false? In a straight run, you can have a maximum of 100 feet between cleanouts. Now, when we talked about cleanouts, we didn't give you anything. We just said, oh, it just refers you back to chapter 7. In chapter 7, where it dealt with cleanouts. What was the maximum distance between cleanouts in chapter 7? I'll tell you what, I'll make it easy on you. We said that was 100 feet was the maximum distance between cleanouts. That'd be true. True or false? On the average, the coast receives a greater amount of rainfall than the mountains. For that one, you'll need to look at that chart or back up the video and look at the chart. Who received the more rainfall, okay, in inches per hour? Was it the mountains or was it the coast? On this one, I tell you, the statement is, I say the coast receives a greater amount of rainfall than the mountains. Is that a true or false statement? Question 3, true or false? Scuppers shall be provided where the roof perimeter construction extends above the roof in such a manner that the water will be entrapped if the primary drains allow buildup for any reason. Is that true or false? Scuppers shall be used if the roof perimeter construction extends above in such a manner that water will be entrapped here if the primary drains allow buildup for any reason. Well, is that a true or false statement? True or false? The approximate rainfall rate for Winston-Salem is 3.5 inches per hour based on the 100-year 1-hour rainfall rate chart. Is that true or false? That Winston-Salem, okay, and we're right in the middle there, kind of that's where I was pointing, is about 3.5 inches per hour based on the 100-year 1-hour rainfall rate chart. Question 5, true or false? A 4-inch circular leader can handle a roof area of 9,000 square feet with a rainfall rate of 2 inches per hour. Is that true or false? Let me flip there and just check, because that's the one I would need to look at the chart myself on to know if that was. So we're talking about circular liters, so it's the top chart. And I say a 4-inch circular liter, so follow the left-hand column down to 4. Now I say that it can handle 9,000 square foot if it's got with a rainfall rate of 2 inches per hour. So if we went over to the 2, and we went from 4 and went across, and we went from the 2 and we went down, and we see where that is, we say, can that handle 9,000 square feet? So if when you look at the block, it needs to at least have 9,000 square feet, as far as will it handle 9,000 square feet? So it can handle, now if the number is smaller than 9,000 square feet, then the answer would say false. If it's anything larger than 9,000 square feet, you could say that's going to say a 4-inch will handle. Let's just say it says 10,000. Now I'm not saying it says, you'll have to look at it and find it yourself. But if it does say 10,000, then the answer would be true. It can handle 9,000 square feet because it can handle up to 10,000 square feet. Okay, so you need to look and find what that number is for the 4-inch circular liter, 2 inches per hour. Question 6, true or false? A roof drain strainer cannot extend less than 3 inches above the roof. It cannot extend less than 3 inches above the roof for a roof drain strainer. True or false? True or false? The minimum diameter of the sump pit is 18 inches. Is that true or false? Question 8, true or false? PVC can be used for subsoil drain pipe. PVC can be used for subsoil drain pipe. So you need to flip over to the chart. It says subsoil drain pipe above it. Look down through the options and see, is PVC listed? If it is, then yes, you can use it. Okay, question 9, true or false? The code does not make it clear on how to dispose of storm water from an individual home. From a residential home, 1 or 2 family dwelling unit, the code does not make it clear on how to handle storm drainage for that. Is that a true or false statement? That was one of the first things we talked about. So if you can't remember that, back it up to when we very first started the discussion with chapter 11, or look at right at the beginning of the chapter. Question 10. A backwater valve, true or false? A backwater valve, when fully open, can be no smaller than the pipe served. A backwater valve, when fully open, can be no smaller than the pipe served. Is that a true or false statement? All right. Well, I hope you do well on your quiz. If you got any questions, reach out to me. So that was a fairly short one chapter. Like I said, it's not the most important chapter as far as for me personally. I feel like you ought to remember there's some other more important things that you just ought to apply to your memory if you're going to say, hey, I'm going to be a plumber. Well, I would rather what the minimum slope requirements are on pipes. So I want you to know what the minimum maximum distance between trap to vents are. I want you to know what minimum size traps are. I want you to remember what the minimum DFU values for all the different fixtures are. I want you to know how far can I run a vent at its minimum size? What is the minimum vent sizes for all these different? That's the information that I really want you to apply and stick to your memory. This is good information as far as, but if I'm looking for something, I'll be like, oh, it's a storm round. I'm just let me look it up. Let me look it up. Okay, that you don't have to memorize some of these charts. But hopefully, by going through this quiz, going through the chapter, you'll know how to read the charts, and that if you get a question on there on your state exam, you'll be able to go and find the information quickly and get that answered. But all right, if you got any questions, reach out to me, and I'll look forward to seeing you next time. All right, bye for now.